Good day all, and welcome once again to my channel. It's been a while that I posted here, but all I can say is that I am back. So this time, I'm going to be looking at a topic in chemistry called electrolysis. I know that this topic, so many students find it difficult, but it's with my hope that after this video lesson, you would understand the intro to the world of electrolysis. All right. So we are going to split this video into 3 to 4 parts. The first part is the introduction to the world of electrolysis. All right. And then we'll now look at the calculations and the uses and some other things about electrolysis. So considering electrolysis as a topic, now this topic is in a branch of chemistry called electrochemistry. Electrochemistry. All right. Now, when you look at this word, whenever you are confronted with a very big word, you know what you do? You try to split the word into syllabic forms that will make sense. What do I mean? Now look at this word. This word is a very big word, electrolysis. But to make sense, I can actually split this word into two parts. And the first part should be what? Electro, which is this first part, electro, while the other part is lysis. So I can say that electro means electricity, electric current, while lysis means to split or to decompose. So in a nutshell, I can say that is using electric current or electricity to splitting a chemical substance. That is electrolysis. So by definition, I can say that electrolysis is simply the chemical decomposition of a compound by the passage of direct current through the compound, either in its molten form, or solution state. All right, either in its molten form or solution state. When we say molten form, we are referring to compounds that when heated, they can be heated to liquids. All right, so when the compound is heated to liquid, it's referred to as molten state of the compound. It's just like we have other words related to this. For example, I guess you must have seen this word before called hydrolysis. Looking at this word hydrolysis, if I split into two parts, I'll be having the first part to be hydro and the other part to be lysis. Hydro means water and lysis means to split. So I can say that hydrolysis is simply the splitting of a compound by the usage of what? Water. All right. So using water to cause the splitting of a substance is called hydrolysis. We still have others like photolysis. Now, photolysis talks about the usage of light to split a chemical substance. All right. So let's see the overview of this electrolysis. What are some terms that are associated with electrolysis? We have terms associated with electrolysis. And what are some of these terms? The first we have is electrolytes. Electrolytes. These are things that you must know about electrolysis. And the second is electrodes. We have electrolytes and then we have electrodes. So let's understand these two terms that are associated with electrolysis. Starting with electrolytes. What are electrolytes? Now, electrolytes are simply compounds that allow the passage of current through them, meaning anything that is said to allow or to permit the passage of current through it is said to be called a good conductor of electricity. So I can as well say that electrolytes are compounds that allow the passage of direct current through them, and in the course of them allowing the direct passage of current through them, they get decomposed. So they are simply compounds that allow the passage of direct current through them and they are decomposed in the process, or they are simply compounds that conduct electricity and are decomposed in the process. All right. Now, don't get this thing wrong. We have elements that conduct electricity and we have compounds that conduct electricity. Pay attention to this. Elements that conduct electricity are called conductors, all right, in the world of chemistry. While compounds that conduct electricity, they are called electrolytes. Don't forget this, please. All right. Compounds that conduct electricity are called electrolytes, while elements that conduct electricity, they are called conductors. Of course, we have the good majority of elements that can conduct electricity to be metals. All right. So what are those compounds that allow the passage of current through them? It is not all compounds that allow the passage of current through them. The compounds, specific compounds that allow the passage of current through them are usually in the form of ionic compounds. Ionic compounds. When we say ionic compounds, we are referring to compounds that when current is passed through them, they can split and then they form charges. You understand? Now, looking at ionic compounds, another name for ionic compounds is electrovalent compounds. Electrovalent compounds, all right? Why are they called electrovalent compounds? It's because they possess electrovalent bond. In your chemistry lesson on chemical combination or chemical bonding, you must have been taught that we have different types of bonds, of which one of them happens to be electrovalent bond. Another name for electrovalent bond is ionic bond. That's the reason why compounds that possess such bond, they are called electrovalent compounds, or you can call them ionic compounds. All right. So looking at electrolytes, there are two types of electrolytes. One, we have the weak electrolytes, we have the weak electrolytes, and we have the strong electrolytes. The weak electrolytes and the strong electrolytes. All right. Weak electrolytes, by the word weak, what does that mean? It means they are compounds that dissociate or ionize partially in solution. They are compounds that dissociate, like they split partially in solution. And what are classical examples of weak electrolytes? We could be having weak acids, such as the organic acids, like we have the CH3COOH, known as ethanoic acid. And then we have our weak bases, such as ammonium hydroxide. This is a weak base. Then we also have weak acids, weak acids such as H3PO4, which is phosphoric acid, and then we have H2CO3, which is carbonic acid. These are actually weak electrolytes. They only dissociate partially. Mind you, take note of that word, partially, in solution. As for some strong electrolytes, of course, it will be direct opposite to the weak electrolytes. Strong electrolytes are compounds that dissociate completely or they split completely in solutions. We have examples as the strong acids such as H2SO4, which is sulfuric acid. Then we have HNO3, which is nitric acid. We have ACl, which is hydrochloric acid. We have strong bases such as NaOH, such as KOH. And then we also have salt compounds, like normal salt compounds, like the Na2SO4, we have the NaCl, and the rest of them. All right. So these are called strong electrolytes. Okay. So that's just the background of electrolytes. They are compounds that conduct electricity and they are needed for electrolysis because, of course, what compounds do electrolytes? They are simply compounds that are able to allow the passage of current through them. So the next is electrodes. Let's see what electrodes are. What are electrodes? Electrodes. Now, electrodes are simply materials in the form of wires, rods, or plates in which current enters or leaves the electrolyte. Don't forget, listen, electrolytes they still remain compounds that carry electric current or they conduct electric current rather. Now, electrodes, they are the ones that supply the current, they supply the current to the electrolyte, and then it is also them that still permits the passageway through which the current leaves the electrolyte. So by definition, like I said, electrodes, they are materials in the form of wires, rods, or plates through which current enters and leaves the electrolyte. And we have two kinds of electrodes. What are they? We have the anode and we have the cathode. Anode and cathode. All right. Now, looking at this guy, anode. Anode is called the positively charged electrode. All right. This is positively charged electrode. Then cathode is the negatively charged electrode. Negatively charged electrode. Please, students, pay attention to what I'm about to say now. If this is positively charged and this is negatively charged, then during electrolysis, one very vital thing that you need to know is this, that during electrolysis, there is a particular type of chemical reaction that occurs. And that reaction is called redox reaction. Redox reaction. So in case you come across a question, for those writing exams, you come across a question and then you are asked that what chemical reaction occurs during electrolysis, the best to go with is redox reaction. Now, looking at redox reaction, I've treated this in one of my video lessons in this channel, so you can do well to visit that video lesson for you to be thorough about this chemical reaction. Because looking at this chemical reaction, there are two reactions that are occurring at the same time, meaning they are occurring simultaneously. Reduction from the word redox. Redox from the word, I can split into two parts. This is reduction and the other part is oxidation. So it means that these two reactions are taking place simultaneously. They are happening at the same time. So that's the reaction that occurs during electrolysis. So the thing is, if we have two reactions that take place during electrolysis happening at the same time, this guy, there would be one of the reactions that will be taking place here, and there will be the other reaction occurring at the other electrode. So now the question is, what reaction takes place here and which one occurs here? Is it oxidation that takes place at the anode or reduction? Is it oxidation that occurs here or reduction? Let's see something. You can use this code to remembering it. Crowd, 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 meaning C to arrow and A to O. I can as well even say that in English we have how many vowel letters? 5. A, E, I, O, U. This is also a code that consonant letter to consonant letter, vowel letter to vowel letter. That's still a code that you can use to easily remembering it. What does all these letters mean? Now, cathode is to reduction, then anode is to oxidation. What does that mean? It means at the anode, oxidation takes place there. Then at the cathode, reduction takes place here. Reduction occurs at the cathode. So oxidation takes place at the anode and reduction takes place at the cathode. All right. And one very important thing that you need to take cognizance of is that initially I told you guys that electrodes are materials in the form of wires, rods, or plates in which current enters or leaves the electrolyte. So it means at what electrode would there be the passage of current entering into the electrolyte? What supplies current to the electrolyte? What electrode gives current to the electrolyte? Now, current enters into the electrolyte through the cathode and leaves the electrolyte through the anode. So it enters through the cathode and leaves through the anode. Don't forget this. All right. So if you even look at a complete setup of an electrolytic cell, it looks like something like this, where you have your beaker or trough. You have something like this, your beaker or trough, and then you have the immersion of the rods within, and then you have, let's say your wire connected to the circuit source, which is supplying the current, and then somewhere around here you have your key, and then you have something like this. And then of course, let's say this is positive and this is negative. Of course, this should be anode, while this one is cathode. All right, anode, cathode. And then let's say in this you are now having, let's say, the solution within this beaker or trough. The solution is actually the electrolyte. You understand the point now? So this somewhere around the battery source, and this is actually the key. All right. So the thing is this: ions are freely moving around when the key is open. Just like, for example, you have A plus and you have B minus. You have B minuses, A pluses. Let's say they are just moving around the medium. And then what happens? The moment you short this key, the law of electrostatics or electromagnetism will be obeyed. In that, you see this positively charged rod, which is known as the anode. Don't forget, I've even written that already. Now, what will happen? Unlike charges will do what? Attract. Then while like charges tend to what? Repel. So this negative B will migrate to what? To the positively charged electrode being the anode. So the B minuses will come here, then while the A pluses will go to the other side. All right. So this is just like an overview as to what you are expected to see in the in-depth of electrolysis. So I just want you guys to know the the intro to the world of electrolysis. All right. So in the next video, I'll be showing you much about electrolysis. So this is like an introduction class. I hope I've been able to explain something that will open your minds to the world of electrolysis and for you to know that this topic is not difficult. It's just your approach towards it that matters. All right. So I hope with this that I've just done, try to go through over and over and over again in this video lesson for you to be able to understand what electrolysis entails. Thanks for watching and do well to subscribe. For those preparing to writing exam, I think the forthcoming JAMB, do well to subscribe to this channel because now I am back and I'll be dropping series of videos that will be of help to you. Stay blessed.